Hello guys, my name Ulul Azmi, and now I want to tell you about the metabolism of lipid. Check this out. Though the term lipid includes several types of molecules, lipid metabolism usually refers to the breakdown and synthesis of fats. Fats are triglycerides. They are esters of glycerol and three fatty acids. Fats can come from the diet, from stores in adipose tissue, or can be synthesized from excess dietary carbohydrates in the liver. Dietary fats are digested mainly in the small intestine by the action of bile salts and pancreatic lipase. Bile salts emulsify fats. They act as a detergent, breaking large globules of fat into smaller micelles, making them more accessible to lipase. Pancreatic lipase then converts triglycerides into monoglycerides, free fatty acids, and glycerol. These products move into the cells of intestinal epithelium, the enterocytes, inside which they recombine again to form triglycerides. Triglycerides are packaged along with cholesterol into large lipoprotein particles called chylomicrons. Lipoproteins enable transport of water-insoluble fats within aqueous environments. Chylomicrons leave the enterocytes, enter lymphatic capillaries, and eventually pass into the bloodstream, delivering fats to tissues. The walls of blood capillaries have a surface enzyme called lipoprotein lipase. This enzyme hydrolyzes triglycerides into fatty acids and glycerol, enabling them to pass through the capillary wall into tissues, where they are oxidized for energy or reesterized for storage. Fats that are synthesized endogenously in the liver are packaged into another type of lipoprotein, the VLDL, to be transported to tissues, where triglycerides are extracted in the same way. When required, fat stores in adipose tissue are mobilized for energy production by the action of hormone-sensitive lipase, which responds to hormones such as epinephrine. Lipid metabolism pathways are closely connected to those of carbohydrate metabolism. Glycerol is converted to a glycolysis intermediate, while fatty acids undergo beta-oxidation to generate acetyl-CoA. Each round of beta-oxidation removes two carbons from the fatty acid chain, releasing one acetyl-CoA, which can then be oxidized in the citric acid cycle. Beta-oxidation also produces several high-energy molecules, which are fed directly to the electron transport system. Fats yield more energy per unit mass than carbohydrates. When acetyl-CoA is produced in excess, it is diverted to create ketone bodies. During glucose starvation, ketone bodies are an important source of fuel, especially for the brain. However, ketone bodies are acidic and when produced in excess can overwhelm the buffering capacity of blood plasma, resulting in metabolic acidosis, which can lead to coma and death. Ketoacidosis is a serious complication of diabetes, in which cells must oxidize fats for fuel as they cannot utilize glucose. Extreme diets that are excessively low in carbohydrates and high in fat may also result in ketoacidosis. On the other hand, diets that are high in carbohydrates generate excess acetyl-CoA that can be converted into fatty acids. Synthesis of fatty acids from acetyl-CoA is stimulated by citrate, a marker of energy abundance, and inhibited by excess of fatty acids. Fatty acids can be converted into triglycerides for storage or synthesis of other lipids by combining with glycerol derived from a glycolysis intermediate.